Hey there, 8th graders. Welcome to today's Hero Smart Academy Explainer. I'm just absolutely thrilled to be your guide today as we explore this hidden, kind of magical world right inside the liquids we interact with literally every single day. So go ahead, grab your notebooks, get your pens ready, and bring that curiosity, because today we're talking about chemical harmony and navigating the basics of the pH scale. Trust me, this is one of those foundational science concepts that's going to make the whole world suddenly make a lot more sense. Now, to kick things off, what do orange juice, bleach, and the water you drink all have in common? I want you to actually think about that for a second. You drink orange juice for breakfast, you might help your parents clean the house with bleach, and, well, you need plain old water just to survive. On the surface, these liquids seem totally, completely different, right? I mean, they taste different, they smell different, they do totally different jobs. But it turns out they all possess this hidden, measurable chemical property. A property that dictates exactly how they behave, how they react, and how they interact with everything around us. Okay, let's dive right into this. Section 1, Order in the Universe, Discovering the Hidden Design. You know, science isn't just some random collection of boring facts to memorize for your next test. It's actually this super exciting, active process of discovering the highly organized rules of nature. And this brilliantly illustrates our foundational principle today. 1 Corinthians 14:40 tells us, "Let all things be done decently and in order." God created a highly ordered, perfectly balanced natural world. It's not just random chaos. It's entirely by design. And all our scientific tools, our equations, microscopes, our measurement scales, they're simply the incredible ways we get to organize our understanding and uncover that divine order. Think of science as how we learn to read the rules of the universe. Now, to understand the specific order of liquids and solutions, we're going to need a very specific tool, which brings us to Section 2, Meet the pH scale, the numbers behind the chemistry. Let's break this definition down nice and clearly because I want to make absolute sure you fully grasp this core concept before we move on. The pH scale is a measurement system using numbers from 0 to 14 to determine how acidic or basic a solution is. Think of it exactly like a ruler, but instead of measuring inches to see how long a piece of paper is, we're measuring the chemical personality of a liquid. Is it sharp and sour, like a lemon? That's acidic. Is it kind of slippery and bitter, like a bar of soap? Well, that's basic. Or is it perfectly balanced? This 0 to 14 scale gives us the precise language we need to describe that personality. Now, what's really interesting about this slide is the perfect symmetry of the system. See how pure water sits perfectly right there in the neutral middle at a pH of exactly 7? It's like the ultimate balancing point of a chemical seesaw. Flanking it on the left, with lower numbers from 0 to 6, we've got our acids. Remember that orange juice from earlier? That's a great real-world example, sitting around a pH of 3. Then on the right side of the center, with higher numbers from 8 to 14, we have our basic, or alkaline solutions. Bleach is strongly basic, hanging out way up there around a pH of 12. And the major takeaway here? The further you move away from that neutral 7, in either direction, the stronger and more powerful that acid or base becomes. So let's move along and see how this builds, because there's actually a hidden mathematical secret behind how this scale really functions. This is Section 3, the tenfold rule, doing the math. And a massive number 10 is the secret key here. The pH scale, it's not like your standard ruler where moving from a 1 to a 2 is just adding one equal unit. No, the pH scale is logarithmic. Now, that's a big science word, but it just means every single step you take up or down this scale doesn't represent a change of 1. It represents a huge, tenfold change in chemical strength. So, the crucial point is understanding this logic step by step. Step 1, let's say we have a mildly acidic liquid starting at a pH of 5. Step 2, we drop down just one single number on the scale to a pH of 4. Now, step 3, you haven't just gotten a tiny bit more acidic. The acidity is now 10 times stronger. It multiplied. One tiny step on that number line equals a giant leap in actual chemical power. All right, let's treat this like a quick interactive challenge. If a pH of 4 is 10 times more acidic than a pH of 5, how much more acidic is a pH of 3 than a pH of 5? I'll give your 8th grade brains a couple of seconds to crunch the numbers. Did you guess 20? Look, if you simply added 10 plus 10, I totally get why you did that, but think about it again. Remember, we're multiplying by 10 for every step. So moving from a pH of 5 down to 4 is times 10. Moving from 4 down to 3 is another times 10. And 10 times 10 is 100, meaning a pH of 3 is literally 100 times more acidic than a pH of 5. That compounding math is exactly why scientists have to handle strong acids and bases with such incredible care. So now that you've got the micro math down, let's zoom out to the macro world. Welcome to Section 4, Why pH Matters, Chemistry in the Real World. See, even microscopic, tiny changes in pH can have massive, life-altering effects in the real world. I mean, pH levels create safe habitats for fish and aquatic plants. If a lake's pH drops just a little bit, say from acid rain, the fish literally cannot survive. Understanding pH is also what ensures the drinking water coming out of your kitchen tap is perfectly balanced and safe. It controls safe reactions in scientific labs, and it's absolutely vital for agriculture, food production, and healthcare. Actually, here's a crazy fact. Your own body is constantly working behind the scenes to keep your blood at a very strict, slightly basic pH of around 7.4. Even a slight variation can make you really sick. So scientists actively monitor these levels everywhere to protect life. It's basically a real-life superpower. But we don't just want to be smart scientists, right? We want to be wise individuals. Let's pivot to Section 5, Education, Morality, and Peace, the whole picture. I want to ask you a really serious question. What is the point of being smart and supposedly educated if you continue to make bad choices that hurt yourself and others? At Heroes Smart Academy, our Godly Learners series intertwines biblical morality directly with your education for this exact reason. An education completely lacks value and frankly can even be dangerous if it isn't paired with a strong moral compass. Being incredibly smart without knowing right from wrong, it's kind of like having a powerful, highly acidic chemical without a safe container to hold it. Eventually, it's just going to cause damage. That's exactly why we look for a higher balance. The book of Romans, chapter 8, verses 6 and 7, offers us this profound promise. It promises peace of mind to everyone who keeps his or her mind spiritual. Think about that for a second. When you gently pair your growing, brilliant scientific understanding of the physical world with a grounded, spiritual mindset, you achieve something so rare. You find true peace. The smartest students aren't just the ones who memorize the pH scale. They're the ones whose minds are at peace because their knowledge is guided by their faith. Which brings us right to the end of our explainer today, and I want to leave you with this final, provocative thought. How will you use your education and your moral compass to recognize the divine order around you and bring peace to the world? It's a big challenge, 8th graders. Your science education gives you the tools to understand the chemistry, the numbers, the tenfold rules, and your faith gives you the direction on how to actually use those tools for good. I want you to think about that deeply as you complete your homework today. Stay curious, keep seeking order and balance, and I'll catch you in the next explainer.